Welcome to NVE Corporation's YouTube channel. We're recapping our 2025 trade show season with a walkthrough of Sensor+Test in Germany and the demonstrations we brought to the exhibition hall. Sensor+Test is billed as the world's leading forum for sensor, measurement, and testing technology. It is hosted at Messezentum Nuremberg towards the end of spring annually. Nuremberg is a major hub for innovation dialogue, hosting other major trade fairs including Embedded World, SPS, and PCIM. We stayed near Pleha station, which had interchange between all three U-Bahn lines. Messe was about 15 minutes away via U1, and packed trains ran every 5 minutes at peak hours. This footage was from the third and final full day, so many attendees had backpacks and luggage with them. The number of attendees was generally impressive, albeit on the known slower third day. NVE Corporation is generally attending Sensor+Test to discuss new and ongoing projects with existing customers, to establish close ties with our vendors and our distribution partners, and to meet new contacts with demanding new applications. But sometimes, we just make friends, like this guy. Sensor+Test covers many different types of sensor technology, of which GMR and TMR are a small but growing subset. NVE Corporation's GMR and TMR sensors are commonly used in industrial applications requiring extreme miniaturization, high sensitivity, and very low power consumption. Common use cases include flow meters, cylinder position sensors, linear actuators, and rotary encoders. We opted for a larger booth compared to last year. While it was still relatively compact, our visitors appreciated the room to walk into our booth and explore the variety of product demonstrations we had available. Usually, we bring many different demonstrations. The closer a demonstration is to an envisioned use case, the easier our customers can visualize our sensor solutions benefiting them. Our new products include ultra-small wafer-level chip-scale package switch sensors, which are as small as grains of sand. We included magnifiers to aid the eyes. We have both two-state switch sensor versions and more complex linear output magnetometer versions of these tiny, low-power sensors. To emphasize we have our own in-house wafer fab, we like to set up an old scrap wafer. I tried taking a close-up shot with my new phone's 10x zoom camera, but the small features were difficult to resolve, a testament to the miniaturization of our parts. The images would have been confidential anyways. Our next demonstration is for a new 2-axis rotation sensor designed for mechanical water meters. It has incredibly high sensitivity and consumes about 1 microamp when powered. It can detect rotation from virtually any orientation, including off-axis locations. We brought back our programmable limit switch, the SM124, which is popular in precision end effectors. For even higher precision and accuracy, the SM324 offers a more sophisticated interface, with up to 24 bits of output resolution. We have a large magnet, and the sensor can detect it from hundreds of millimeters distance. The red LED shows the sensor's programmable digital switch output. Here's the sensor. The evaluation board also has a conductor running under the sensor for current sensing. We had a cylinder position sensor demo using our new advanced dual output switch, ADA32124. This demo shows secure and insecure mounting positions for the sensor assembly. The two sensor states can also be used to save power by predicting the end of cylinder stroke. We had our encoder demonstration, showing how TMR sensors can be used for linear actuators or stages. We've shown this demo before on our channel. Check the link in the description for the full video. The LEDs show the proximity of the sensor to a magnetic pole on the magnetic scale. The sensor detects these pole faces and interpolates the position to micron precision. Our new omnidirectional TMR technology was showcased in this flashy LED ring demo. These sensors are designed to detect large magnetic fields in applications like flux leakage detection, magnetic levitation, and magnetic imaging via scanning. The sensor detects the magnetic field irrespective of the direction the magnet approaches it. The sensor is a tiny 1 mm square and consumes very little power. We brought back our tiny gear sensing demonstration, where an ABL006 GMR gear tooth sensor detects the RPM of a shaft by reading the movement of a gear with tiny sub-millimeter teeth. We'll go in for the close-up shot, but pay no mind to the dust created by accidentally pressing the gear teeth into the sensor's plastic encapsulant. While this is a sensor show, our GMR sensing technology is also used to transmit data across the robust isolation barrier in our isolator products, which are rated up to 7 kilovolts. One of the first questions we're often asked at the show is, what does your company do? We find the simplest explanation is to hand them 100,000 pieces of our products. Therefore, we made this demo. The parts here are only 1 mm square, which is small enough for them to annoyingly get caught in the threads of this cap. We had one more GMR isolator demonstration with our IL-DC11 integrated isolated DC-to-DC converter. This is the world's smallest isolated DC-DC converter, measuring just 3 mm by 5.5 mm. We also have isolated data couplers with integrated DC-DC converters. We brought back our legacy off-axis angle sensor demonstration, showing how NVE's TMR angle sensors AAT003 can be used to create rotary encoders with wider mounting tolerance. The magnet pockets show where the sensor has ideal linearity. The sensor is the small chip in the center. We don't print catalogs anymore, but we find that business card handouts work better than memory alone. They are compact and help people contact us. Lastly, we have our smart GMR chessboard, which uses 64 position sensors to detect the pieces from a magnetic chess set. We'll reset the game, start a new one, and show how it works. Our CPU detects which piece was lifted and where it was moved, and then prints the action on the LCD screen. Each player has their own screen on opposite sides of the board. The pieces have LEDs underneath, and they're triggered by the sensors in each square. When we move a piece, the LED follows it. That's because the sensors are detecting the position of the magnets on the board. Anyways, it's back to work for us. Thank you to everyone who visited our booth this year. We hope to see you again soon. If you have questions in the meantime, click email or call for more information, and to subscribe to NVE's YouTube channel for more product demonstrations.